What if everything you thought you knew about the Egyptian pyramids was based on just 1% of what's actually inside them? Imagine peering into a time capsule sealed for over 4,500 years. Recent scans using Muon radiography have revealed massive chambers that challenge our current understanding. In this documentary, we'll take you inside these newly discovered spaces and show you how advanced technology is completely rewriting our understanding of these ancient monuments. From mysterious voids 98 feet long to engineering techniques that baffle modern architects, the pyramids are finally giving up their secrets. From primitive torchlight explorations to cutting-edge scans, our journey through these ancient structures is just beginning. Imagine standing at the base of the Great Pyramid of Giza, its massive limestone blocks towering nearly 500 feet above you. What would compel you to venture inside this colossal structure with nothing but primitive tools and flickering torchlight? For centuries, the pyramids stood as silent sentinels in the desert, their inner chambers and passageways shrouded in mystery until the first brave explorers decided to breach their walls. The earliest documented pyramid explorer was the Greek historian Herodotus, who visited Egypt around 450 BCE. His accounts, though historically inaccurate, sparked Western fascination with these monuments. Herodotus described subterranean chambers beneath the Great Pyramid connected to the Nile River and recorded legends of immense treasures hidden within, inspiring centuries of treasure-seeking expeditions. Building on this early curiosity, Caliph Abdullah al-Ma'mun in 820 CE led a team driven by tales of pharaonic treasures. Their hearts pounding with anticipation, his workers tunneled horizontally near the pyramid's base when they couldn't locate the original entrance, creating al-Ma'mun's passage. After breaking through into the descending passage and circumventing massive granite plugs, they reached the king's chamber, only to find an empty sarcophagus. Their disappointment was so profound that al-Ma'mun reportedly planted treasure for his men to discover to prevent mutiny. Medieval explorers continued the quest, operating under a peculiar mix of religious superstition and treasure-hunting zeal. Arab historian Abd al-Latif noted in the 12th century that many made it their business to explore the pyramids, seeking treasures. These adventurers often damaged artifacts and carved their names into ancient walls while perpetuating fantastic stories. A shift toward more systematic study began with Napoleon's 1798 Egyptian campaign. Napoleon himself requested time alone in the king's chamber and emerged visibly shaken, cryptically stating, "You would not believe me if I told you." This mysterious incident has fueled centuries of speculation about what he might have experienced. The 19th century introduced more methodical explorers like Giovanni Battista Belzoni, a former circus strongman who became the first modern person to enter the Pyramid of Khafra in 1818. His journals revealed the dangers these early explorers faced. We had to crawl through passages choked with sand and debris in complete darkness with the constant fear of cave-ins. Vyse took destructive approaches further in the 1830s, using gunpowder to blast through the Great Pyramid's upper chambers. Despite his questionable methods, Vyse discovered several previously unknown relieving chambers, though at the cost of invaluable archaeological evidence. Throughout these centuries of exploration, the misconception that slaves built the pyramids took root. Recent archaeological discoveries have revealed evidence of skilled laborers who received proper burials, medical care, and substantial food rations, including prime beef. Graffiti shows workers organized into teams like Friends of Khufu, while analysis of remains shows sophisticated medical treatment, hardly the experience of slaves. As evidence mounted that skilled craftsmen, not slaves, built the pyramids, Another myth was about to be shattered, the notion that ancient Egyptians possessed only primitive mathematical knowledge. When Flinders Petrie arrived at the Giza plateau in 1880, he brought something revolutionary. Not treasure maps or digging tools, but measuring instruments of remarkable precision. Petrie, a Victorian archaeologist with an obsession for exactitude, transformed our understanding of ancient Egyptian capabilities. While others sought gold or mummies, Petrie sought numbers-detailed measurements revealing these monuments' true nature. For 2 years, he meticulously documented the Great Pyramid's dimensions using simple but carefully calibrated tools. His discoveries defied expectations. The casing stones once covering the Great Pyramid fit together with joints averaging just 0.5 millimeters, thinner than a credit card. This precision would challenge even modern craftsmen equipped with advanced technology, yet ancient builders achieved this without power tools or laser levels. This exactitude extended throughout the entire structure. The pyramid's 4 base sides showed an average error of only 58 millimeters, about the length of a modern smartphone, across distances exceeding 750 feet per side. Such mathematical mastery manifested across every aspect of construction. The mathematical sophistication continued in the pyramid's proportions. The ratio of perimeter to height approximates 2 pi with remarkable accuracy, better than 0.05%. This relationship raised profound questions. Did ancient Egyptians understand pi thousands of years before Greek mathematicians formally defined it? Some Egyptologists believe this mathematical encoding was intentional, suggesting advanced knowledge, while others consider it potentially coincidental. Petrie's work also revealed the pyramid's original appearance. Rather than the rough, stepped structure visible today, it once stood completely encased in polished white limestone that reflected sunlight with dazzling brilliance. Imagine the awe of ancient visitors approaching this gleaming mathematical mountain rising from the desert floor, visible for miles around. The precision Petrie documented challenged fundamental assumptions about ancient capabilities. A civilization working with copper tools achieved construction tolerances that would impress modern engineers. These weren't crude monuments, but carefully engineered structures requiring advanced knowledge and extraordinary organization. Just as each stone fit precisely with its neighbors, the entire pyramid aligned with cosmic precision. The 4 sides orient almost perfectly to the cardinal directions, with an average deviation from true north of merely 3 minutes and 38 seconds of arc, approximately 1/10 of a degree. Without modern instruments, ancient Egyptians achieved alignment accuracy that would challenge contemporary surveyors using basic tools. This astronomical precision indicates sophisticated methods for determining true north, likely through star observations. Combined with the mathematical relationships embedded in the dimensions, these alignments suggest the structures serve purposes beyond being mere tombs. They were physical manifestations of cosmic order, engineered with a precision that continues to astonish us today. The architectural precision of the pyramids posed a tantalizing question. If their external structure contained such mathematical and astronomical sophistication, what hidden marvels might lie concealed within the stone itself? For millennia, this question remained largely unanswerable. Explorers could only access what physical tunnels and chambers allowed, leaving the vast majority of the pyramid's interior completely unknown. That changed dramatically in the mid-20th century when scientists began applying physics to archaeology in revolutionary ways. In 1967, Nobel Prize-winning physicist Luis Alvarez proposed using cosmic ray muons to essentially X-ray an entire pyramid. These subatomic particles, created when cosmic rays collide with Earth's atmosphere, constantly rain down on our planet, passing through most matter but being absorbed at different rates depending on density. By placing Muon detectors inside Khafre's pyramid and measuring particle penetration from various angles, Alvarez hoped to detect internal voids. The premise was elegant. Areas with fewer stone blocks would allow more muons to pass through, creating distinct patterns in the detectors. However, the technology proved inadequate for the massive monument. The results produced confusing data that led to no significant discoveries, highlighting the immense challenges of non-invasive pyramid exploration. The sheer mass of stone, combined with limited detector sensitivity, kept subtle internal features hidden for decades. Progress resumed with the Upuaut Project in 1992 to 93. German engineer Rudolf Gantenbrink designed a robot named Upuaut, which means opener of the ways in ancient Egyptian, to explore narrow shafts extending from the Queen's Chamber of the Great Pyramid. These passages were only about 8 inches square, far too small for human exploration. Gantenbrink's robot, equipped with lights and a camera, ascended the southern shaft until it encountered something unexpected: a small limestone door with copper fittings blocking the passage. This discovery electrified the archaeological community. What purpose could these shafts serve, and what might lie beyond this mysterious barrier? The space beyond remained unexplored for nearly 2 decades, until the Djedi Project in 2011 developed technology advanced enough to investigate further. Named after the magician whom Khufu consulted when planning his pyramid, the Djedi robot incorporated a flexible microsnake camera that could be inserted through a small hole drilled in the limestone door. The camera revealed something remarkable: red hieroglyphic markings on the hidden side of the door. These markings, invisible for thousands of years, suggested that the internal structure was far more complex and intentional than previously understood. What once seemed like dead ends were actually designed features, potentially guiding the way to something beyond. While these internal explorations progressed, archaeologists also uncovered the fate of the pyramid's exterior. The smooth white limestone casing that once made the pyramids gleam in the desert sun had largely disappeared. Historical records revealed that following a massive earthquake in the 14th century that loosened many casing stones, the smooth white blocks were systematically stripped away and repurposed for buildings in nearby Cairo. Many of the city's oldest mosques and fortifications contain stones that once formed the pristine outer layer of the Great Pyramid. While Cairo's buildings absorbed the pyramid's outer glory, the true revolution in pyramid exploration was happening at the subatomic level. In 2015, an international team of scientists launched the ScanPyramids Project with an ambitious goal to see through solid stone without moving a single block. Their method? Using cosmic particles that rain down on Earth from distant stars and galaxies. These particles, called muons, are created when cosmic rays collide with Earth's atmosphere. They penetrate matter differently depending on its density, passing more easily through empty spaces than through solid stone. This physical property makes them perfect natural X-rays for massive structures like the Great Pyramid. By placing specialized detectors around the monument, scientists could create a shadowy image of the pyramid's interior, revealing what had remained hidden for 4,500 years. The process demanded extraordinary patience. Muon detectors remained in position for months collecting data. The team employed 3 different technologies simultaneously: nuclear emulsion films, scintillator hodoscopes, and gas detectors. This redundancy ensured any discovery would have confirmation from multiple independent sources. In 2016, patience yielded their first major discovery: an unexpected void behind the north face of the pyramid. This corridor, about 5 meters long, was detected just above the monument's original entrance. The finding was significant both for what it revealed and for validating their methodology, suggesting other hidden spaces might await discovery. The team's confidence grew when, in February 2023, they verified this discovery through direct observation. Using an endoscopic camera, they explored the corridor, finding it extended 9 meters horizontally, with a cross-section of approximately 2 by 2 meters. The north face corridor represented the first previously unknown internal structure discovered in the Great Pyramid since the 19th century. As more data accumulated, their computers began rendering images of something much larger, an enormous void situated directly above the Grand Gallery. This space was massive, at least 30 meters long, with a cross-section similar to the Grand Gallery below it. I remember staring at the data in disbelief, one researcher recounted. We were looking at something enormous that had somehow remained hidden for millennia. The feeling was indescribable, like making eye contact with history itself. To ensure accuracy, the team verified the big void's existence using all 3 detection technologies. Each confirmed the same finding, a genuine architectural feature that had somehow remained hidden throughout centuries of exploration. The purpose of this enormous space remains a mystery. Some theorize it might be a construction gap related to building the Grand Gallery, while others suggest it could be a chamber with potential ritual significance. What makes this void particularly tantalizing is its complete isolation within the stone mass, with no apparent entrance. We know it's there, but we can't reach it, noted another team member. At least not without damaging the monument, which is absolutely out of the question. The ScanPyramids Project represents the perfect marriage of cutting-edge physics and ancient archaeology. What's remarkable is that these discoveries occurred in perhaps the most studied ancient structure on Earth. After thousands of years of exploration and 2 centuries of scientific investigation, the Great Pyramid still conceals secrets that only our newest technologies can reveal. The secrets inside the pyramid are extraordinary, but perhaps the greater mystery stands in plain sight: the pyramid itself. How did a civilization without wheels, pulleys, or iron tools construct such a precisely engineered monument 4,500 years ago? A recently discovered ancient diary may finally provide answers. The sheer scale of what the Egyptians accomplished is staggering. They quarried, transported, and positioned 2.3 million stone blocks, some weighing as much as 80 tons, with joints so precise you couldn't slip a credit card between them. This feat would challenge modern construction firms with all our advanced technology, yet the Egyptians accomplished it using copper tools and human ingenuity. The Diary of Mira, a collection of papyrus documents dating to the 27th year of Khufu's reign, transformed our understanding of how this was possible. These ancient logbooks detailed the transportation of white limestone blocks from Tura quarries to Giza, revealing a sophisticated logistics system. One entry reads, Day 25-4. Zhao teams delivered 7 blocks to the harbour master at dawn. This rare glimpse into daily operations shows the Egyptians weren't just master builders, they were exceptional project managers, coordinating resources with remarkable precision. Workers were organized into specialized units called Zhao, each consisting of 40 men, functioning like an ancient assembly line orchestrated with precision. These larger groups were further divided into smaller teams with designated leaders, creating a hierarchical structure that efficiently directed a workforce of approximately 13,200 people, with peak numbers reaching around 40,000. This organizational sophistication challenges the old notion of masses of slaves toiling under the whip. Their stone-cutting techniques were equally ingenious. Using simple copper tools and wooden wedges soaked with water, workers could break and shape massive stone blocks with remarkable accuracy. Not only was the technique innovative, but so was the management behind it, turning technological limitations into engineering triumphs. The transportation challenge required an elaborate ramp system, likely spiraling around the structure or zigzagging up one face, allowing teams to haul stones to any level as construction progressed higher. This process, requiring thousands of coordinated workers, operated with the precision of a modern manufacturing facility. The Egyptians integrated advanced engineering concepts throughout the structure. The king's chamber presented a significant architectural problem, preventing the immense weight above from causing collapse. Their solution was a series of relieving chambers that distributed weight away from the ceiling, demonstrating an intuitive grasp of engineering principles thousands of years before they were formally codified. The precision achieved without modern tools remains astonishing. The pyramid's base deviates from a perfect square by less than 0.1%, despite spanning more than 230 meters on each side. Some stones fit together with joints mere fractions of a millimeter wide. These construction techniques reveal a civilization that mastered logistics, materials science, structural engineering, and workforce coordination at a level that should have been impossible, given their technological limitations. The pyramid stands as evidence of a culture with sophisticated planning, mathematical understanding, and engineering intuition that continues to impress us 4,500 years later. While the engineering behind the pyramids astounds us, the alignment precision suggests a purpose even more profound than housing royal remains. When you stand at the Great Pyramid's base and look up, you're witnessing a structure deviating from true north by barely 3 minutes and 38 seconds of arc, an accuracy comparable to hitting a target a mile away with a deviation smaller than the width of a human hair. This precision raises a compelling question. Were these monumental structures actually designed as astronomical calculators encoding mathematical knowledge? Ancient Egyptians developed several ingenious methods for achieving this remarkable alignment. They combined techniques like the solar gnomon method, tracking shadows throughout the day, and the pole star method, using sightlines to track celestial positions to establish accurate directional baselines. Most fascinating was their possible use of the simultaneous transit method around 2500 BCE, when stars Mizar and Kochab formed a vertical line pointing almost exactly to true north, creating a celestial plumb line for the builders. The pyramid stands as a cosmic clock, its measurements calibrated to the rhythms of the heavens. Its distinctive slope of 51 degrees, 50 minutes and 40 seconds creates proportions that encode the golden ratio, a mathematical constant appearing throughout nature. This same slope, combined with the pyramid's base measurements, generates the famous approximation of pi in the perimeter-to-height relationship. These astronomical alignments served deeply religious purposes in Egyptian cosmology. The pharaoh's journey after death was explicitly celestial. The orientation facilitated the king's ascension to join the imperishable circumpolar stars that never set below the horizon, symbolizing eternal life. This cosmic connection manifests physically within the structure itself. The mysterious shafts emanating from the king's chamber, once dismissed as mere ventilation ducts, align with specific celestial bodies, creating literal starways for the pharaoh's spirit. They functioned as symbolic pathways, connecting the entombed king with the cosmic realm he would join in the afterlife. The recently discovered voids within the Great Pyramid deepen these astronomical connections. The big void above the Grand Gallery may have served as an observation chamber or part of a complex system for tracking celestial movements. As our scanning technologies advance, these ancient mysteries may soon find modern answers. Scholarly debate continues over whether these relationships were intentional or coincidental. Skeptics suggest the patterns might be byproducts of practical construction, rather than deliberately encoded knowledge. However, the accumulation of evidence, from the precise north-south alignment to the mathematical constants in the structure's proportions, increasingly suggests deliberate design choices. If intentional, the implications would be profound. The pyramids would represent not only royal tombs, but sophisticated scientific instruments and repositories of mathematical knowledge, stone libraries preserving cosmic understanding for future generations. Could these massive structures be ancient scientific instruments hiding in plain sight? Were the chambers and passageways carefully positioned to track celestial movements that would otherwise be invisible to naked-eye observers? The newly discovered hidden chambers may contain the evidence that finally answers whether the Great Pyramid was designed as Egypt's first astronomical observatory. What is truly remarkable about the ancient Egyptians isn't just what they built, but how our understanding of their achievements continues to evolve. As Mark Lerner notes, the Great Pyramid contains architectural complexities we're only beginning to appreciate through modern analysis. The coming years promise even more revelations. With each technological advancement, from thermal imaging to AI-assisted analysis, we inch closer to comprehending the full scope of Egyptian innovation. These structures weren't just monuments to the dead, but embodiments of a sophisticated worldview we're now painstakingly reconstructing. The pyramids stand as time capsules of knowledge waiting to be decoded. Stay tuned as technology continues to unlock more secrets of our past, reminding us that history is never fully written. It evolves with each new